Can you hear me here? Okay. Welcome. So this is the Silicon Valley Deep Learning Group. So if you're on the wrong aircraft, this is your last opportunity to go to the correct meetup. This is our our 20-something meeting. I guess Sophia is calculating that right now as we talk. The group has grown over the last 2 years from just a tiny crew of people to some more than 4,500 members in more than 20 countries. So thank you everyone for coming and participating and enjoying. We now videotape everything, and all the videos are on the internet, so you can also watch the videos on YouTube if you miss anything, or you want to recommend one to a friend for a great talk that you heard. Hopefully tonight it will be one of those. So I'm Adrian Kaler. I'm the host, I suppose. I would like to take a moment before we actually begin with our talk to introduce and thank some of our sponsors. And let me start with Hari from Wipro, who is representing the company that has given us this beautiful space tonight, not to mention tasty pizza. And I'll give him an opportunity to tell us a little bit about Wipro and what Wipro is doing today.
Thank you, Adrian. Welcome to Wipro. We're glad that all of you showed up. It's a Monday evening, and I know you guys fought traffic to get here. So appreciate that. It shows your commitment towards the topic and to learning more, right? So essentially, Wipro is doing a lot of work that's interesting in the machine learning space and a bunch of areas to foster innovation, right? So these events are a part of how we engage with the broader ecosystem and the community. And really, AI machine learning has so many interesting aspects, right? Whether you're looking at facial recognition, audio processing, NLP, NLU, and so on. So really, if you're looking to connect with startups, we're looking to connect with passionate individuals, we're looking to connect with universities and so on, so that we can engage with these folks and build solutions for our customers. So this is a very interesting area. So we're passionate to hear about your thoughts and topics, so do come to myself and my colleagues to chat with us after the event, and we're always around here to connect with later as well. So again, thank you for coming over, and I hope you enjoy your time here and learn a lot more as well.
Thank you, Hari. So yeah, everybody remember that, of course, we have time set aside to network and meet new friends and so on. And it's also a great time after the talk to talk to our hosts and their representatives. They have a very exciting AI program going here at Wipro, so I'm sure they'd be happy to hear from you and talk to you about whatever you're doing as well. I'd like to also thank another of our sponsors, which is Royce Law, and Steve Colby is going to tell us a little bit about what Royce Law is doing.
Hi, welcome to the event. So happy to see so many people here. So I'm a patent attorney. I'm the director of the patent group at Royce Law. We're a full-service law firm, but small. We specialize in representing early-stage startups in corporate, IP, employment, in many other different areas of law. And we are located in San Francisco and Menlo Park. I'll be around afterwards. If you have any questions for me, I'd be happy to answer them. Thank you.
Thank you, Steve. So, Royce Law is a great resource for small companies, people starting up. Steve is an excellent patent attorney. I recommend that you talk to him a little bit after the talk is over and see how you can help him and how he can help you. Before we get started, I also would like to thank two additional people who played an enormous role in running these events. I'd like to thank my co-founder, Sophia Viklund, over here. We can all give her a big hand. And our co-organizer, Allison Doe, who's here just in front, currently simulcasting us around the world. Okay, without further ado, let me introduce Dr. Ray Sun. So I first met Ray in Beijing, in China. Ray-san is the founder of Banter, which is an AI-based startup focused in computer speech and natural language processing. Ray is an expert in this subject, and he is going to give us a bird's eye view of natural language processing. And he is, well, let's just sit back and enjoy the show and hear what he has to teach us.
Okay. Maybe I stand here because I have to, change the slide. So I met Andrew a couple of months ago in Beijing, and so for tonight, this is a short version because usually I run through several hundred of slides and for 4 or 5 hours tutorial. But this one I cut very short version, and hopefully it's, you enjoy it. And if you have a question, we can discuss later on. Okay. Yeah. Go ahead. So this is my background. So that's the purpose, just to give you a very high level overview about what is NLP or NLU. So NLP stands for natural language processing, and the NLU is a subset of NLP. It's called natural language understanding, so it's more challenging than regular NLP. So I list a bunch of the reading list. They are very useful. First one is NLTK. So NLTK is one of the most popular the NLP tool you can use. And then there are several good books from Jaraski, Chris Manning from Stanford, and some of Stanford notes, and the deep learning the textbook. So. And there are this a bunch of tools: NLPK, Python, scikit-learn, TensorFlow, and so on, and Spicy. So before we start, does everyone know the Turing test? Okay. So it is to test, the intelligence. This is one of the very original idea in Turing's thesis. Is ask interaction between the human and the computer, and see how much the computer really can understand and can answer. And subsequently, there are some development by the MIT professor called Joseph Weizenbaum. So he using the pattern matching and preset the answer and to simulate the understanding. So this is happened during the 1960 and 66. And then the further step is to develop the understanding. So the Terry Wingers is the professor now at Stanford, and this is his thesis. He's writing a very famous the program to simulate, how to interact with asking the question and to answer the pyramid. And in these days, there are many the chatbot or the virtual assistant related tool like Siri, like Echo, and so on. And now I just using one example to show you, how typically we using, especially in my startup Banter. So the scenarios come from the friend I met at Chicago O'Hare. So he is a business guy. He is rushed to go to his anniversary with his wife to go shopping quickly, for the dinner, and then he needs some advice for the gift. Then he asked the Banter. So Banter is me. So he asked me, how can we help to find the black cocktail dress? And then we doing some conversation, and in order to understand He's exactly what he needs, and then provided the answers. So, and after the several conversations, he looks very happy. But unfortunately, this video has some problems, so I cannot display today. But if you are happy later on, I can send you a link, then you can play. So the idea is, when Mario asks a question, do you have a black cocktail dress? And then the chatbot answer, I can help you with that, and we have a good choice of a cocktail dress, and blah blah blah. So what is the the thinking process behind from the question to answer? So that is how the NLU is trying to do. So step number one is called parsing. So parsing basically is mapping your question into a certain syntactic structure. So syntactic structure like English, German, French, Chinese, whatever. So at least for language itself, it has some structure to map into. Otherwise, if you mix all the languages together, people may be very difficult to understand what you say. So that's the first step. It's called a parsing. The second step is understanding. So so the parsing itself just recognize the structure. And the understanding is to understand the content, the semantics, and which one, what the people mean. And then the third step, we call it reasoning. So in order to generate reasoning, we need to understand the intent, what the speaker try to communicate. And based on that, we have the background facts with the intent, so we can generate appropriate answer, to the customer to answer the question. So that is my whole topic tonight. Will cover those three steps. And then to build the good NLU engine actually is very difficult. I can tell you why to the end of the presentation. But you can understand the computer want to understand what humans say. You need to map into a certain concept, and that's a concept. To construct a concept is not an easy job. So especially you want to generate a general concept is almost impossible. The second one is how to think. The reason that's still very tough question from the day one of the AI up to now. Still very difficult. I don't know how humans are thinking and computers are thinking could be the same, because computers rely on the logic and the human can think logically or non-logically. Right? And the third one is how the computer can generate consistent and coherent answer. So in order to answer the question match what the customer, the user really want to know. So this is a challenge. And this is the brief history. So from 1960, 70, and you have some development on the speech recognition, and from the 90 to 2000, they involved in a lot of the statistic technology into the different part of the linguistic and the information retrieval field, like conditional random field and latent DS rate allocation. And then a few years ago, now it's just mixed multiple methods into this field. So this field is very challenging, sophisticated, and with different piece of the knowledge. Still, people try to figure out what is the best way to build appropriate, and that's what I like to communicate with everyone. So the next the topic is parsing. So as I said earlier, parsing is to map in the sentence, the question or the utterance into the structure. And so typically, there are four types of the parsing into a syntax. Is the POS, shadow parsing, context-free grammar, and the dependency parsing. So this part I just quickly go through a little bit. linguistics. So you don't need to remember everything, but there's just some terminology for you. So the part of the speech in general is, in English language, the word is the most basic elements, and they are divided in a school. You teach in the 9 components. So this is a well-known, the tagging method. So like a noun, pronoun, verb, adjective, adverb, and so on. And then there are many research has been involved in this field, like the Brown corpus on the hidden Markov model and dynamic programming and supervised tagging. So there are several areas people focus for the decades in this area, try to figure out what is the best way to do the tagging, the task. And so I use the very famous quote from Groucho Marx. So he is the famous American comedian in the 20th century. So one of his famous quotes, "I shot an elephant in my pajamas." So grammarly is correct, but we want to use in this sentence to exercise the different linguistic parsing method. So if you run one of the tools is very useful, it's called the Stanford called NLP. So you can use the Stanford called NLP to do the parsing. So the parsing actually it will assign each word appropriate the label or tag. And the second one is the shallow parsing. So the shallow parsing is more advanced than the post tagging. The post tagging just you can think it's like a tree, right? So it's a flat tree. So every node is the leaf, and each leaf has associated the tag. And for the shallow parsing is to avoid this kind of thing. You may want to group a certain word together and assign a tag. So that is called the shallow parsing or the chunking. So I use the NLTK to do the example. So you can use the NLTK chunk, and then you have to create the sentence with the appropriate tag, and then define your grammars. Then you can display something like this is called the shallow parsing. So shallow parsing has a hierarchy. It's not flat, and a certain the word like an elephant now it's grouping together as a noun part. So then you can compare the shallow parsing and the post tagging. So post tagging is flat, and the shallow parsing is like 1 or 2 layer hierarchy. The reason is to simplify the processing. The third one is called context-free grammar. So context-free grammar is a well-known the method using in the compiler design. So it's just write a set of rules and to describe the language recursively. So and then to represent a certain pattern like HTML is a famous the context-free grammar user can define. And there are several the famous algorithms like CUIK, earlier parsing, or chapter, or the chat parser. So chat parser is currently available in the NLTK. So this one I use quite a lot, and it's very useful to to generate the complete the parsing tree. So again for this method, then you have to define your the grammar. So the grammar first part is a rule. So like S is a sentence. So sentence split into 2 parts. It's a noun part, NP, and the verb part. And also the second rule in this grammar, it says the preposition part is split into preposition and the noun part and so on. And then in here, then we defined a certain, the words. So the word elegant and the pajamas are mapped into noun. So this is very similar to the compiler design we use. So, and then when you, input a sentence, I shot an elephant in my pajama. By split, then you do run through the chart parser. Then you can see the result like this way. So you can see the left side and the right side are all correct. So it means when you're doing the complete parsing, you may have more than one structure. Then which one is correct? Then this is the problem. So it says just based on the structure, we cannot tell what the speaker means. Is the left one or the right one? Both are correct. And the next one is called the dependency parsing. So dependency parsing is a little bit tricky. So dependency parsing is a look at the word and the relation between this word and the neighboring words. So and then this is some of the simple grammar we can define here. Unfortunately, the NLP doesn't provide this approach. So we have to manually define some approach like using the projective dependency parser in order to simulate dependency parsing. So here is a result. I compare the dependency parsing using this indirect NLP method and the Stanford core NLP. So Stanford core NLP is a very nice parser. So you can use that to simulate all kinds of different the parsing method we just discussed before. And so for example, like the I is a noun, and it's a subject of shop. So shop is a verb, and so on. So that is show the age is the indicated relationship between the two words. So this is what we call the dependency parsing. And if we compare, the different parsing methods, dependency parsing and the context-free parsing, you can see the context-free parsing always comes with a certain tag, but the dependency parsing, the word can be the lead or the non-lead. So, but the structure is very similar. So then some of the research is then can we combine both two methods together in order to define the parsing more intelligent. So that's one of the ongoing research on this field. And the next one I'd like to share is understanding. So understanding is means what does it mean in a sentence. So the idea is to analyze the semantic. So this is a famous the information. It's called the distributional semantic. Means a word, the meaning of a word can be determined by the neighbor. So therefore, if there is a certain or the similar distribution of the word, then you can use can or may have the similar meaning. So that is a very strong the hypothesis called the statistical semantic hypothesis. And a lot of the modern the machine learning method is all based on this hypothesis. So you measure. So first thing is given a sentence, you decompose by word, and then you measure the distance between the target word and the neighbor word, and then that is we call the similarity. And based on that, we can use that to do a lot of and the analysis is based on the distribution and understand the correlation between a certain sentence. So next, I will show you some example. So there's a very famous example called George Washington. So George Washington is certain is the first president of the United States, but the George and Washington together, that can mean very different things. Like George lives in the 325 Washington Street. George graduated from the Washington Medical School in 2014, and so on. So the distance between the George and the Washington, we can measure how closely a sentence is talking about George Washington. So it is to say the closer between the George and the Washington, the stronger semantics, the strong semantic relationship indicate. Otherwise, it's just a syntax relationship. So it means from the previous the parsing method, it just show the weak condition, and now the semantic show a strong condition of a certain content in a sentence, and that is how we want to know in understanding. So how close we can understand if we have a multiple tree, which one is the speaker intent. And the neighboring word can also affect the meaning, like the University of Washington, Prince George visit University of Washington, and the George the company is in Washington. So that could mean dramatically different. Even the distance looks the same, but the meaning could be different. So you need to look at some other neighboring word in order to determine the right meaning of a certain phrase we are talking to. So how to use that? So this is a very similar. We can usually measure the similarity. George Washington was the first president of the United States, and the Queen Elizabeth I first was the Queen of England. So that's some you can sense there a certain analog in the structure. Right? On the Andrew Agassi was a tennis champion. Michael Jordan was the best basketball MVP, and so on. So that is we trying to understand if we have a system of the knowledge like that. If given a new sentence, can we analog and find out that is exactly the corresponding situation, and therefore we can indirectly or directly find the solution. Yeah. So we go back to the give advisor case. Now we assuming the Mario like to give his wife the gift. The three case: the black cocktail dress, the pink shirt with a toe boots, or the Gucci handbag. And then the banker want to help to search the information in a way. So how did he do that? Typically, it's like the search engine. So you have the three query, the three terms. So we can break down by the term, and then you can search, the occurrence in each web page. So for example, in this case, we just show the A web page, and then we can counter the occurrence. Saying black happened twice in the document 1, and the cocktail happened 3 times in the document 3, and so on. So this is the first thing we do the semantic analysis is try to form we call the term document matrix, and then based on the matrix we doing some normalization. So normalization is we have to consider the term frequency and also the term occur in the document. And then this is called a TF-IDF. So TF-IDF is just to normalize what we see previously in this matrix. And then there's some math we play. So if you know the linear algebra, you definitely know you can play the singular value decomposition. And so the beauty of the SVD is you decompose it into the 3 matrices. So including the 2 U and V are the normal matrix, and the sigma is the diagonal matrix. And the diagonal matrix has the property is a singular value, is a descending. So it means that if you can truncate a certain single value, you can reduce the matrix. Say I want to have the threshold up to 0.1, so you can consider any threshold, any single value greater than you want to keep. That is we can use it for the recommendation engine design. And this is also very helpful to we perform the dimensionality reduction. So which is you have a giant the term document matrix trillions of the entry. How you want to select something very important quickly? So that is one of the methods we frequently use. And then so what I say here is you can see in the middle, so you have a sigma and a sigma prime. The sigma prime is has the smaller set of the eigenvalue, smaller set of the singular value. So it means when you do that, you will generate approximate the matrix, which is A prime. So A prime is approximate of A, but with the reducer size, so you can have a better control, to run the recommendation engine, or you can do the some like Google's PageRank. So, and in the information retrieval, this is called the latent semantic analysis. So the U has a special name, is called the topic, and or the concept, and this is called the topic model. And but the challenge here is how to choose the the right rank. The right rank is the number of row or the number of column in the middle in the sigma prime matrix, and how you interpret the topic. So how many topics do you need to interpret the result, and also you want to consider how many columns or how many rows enough for you to provide enough interpretation of the analysis without going to very very sophisticated or very large computation. So I used to have this example and run through the LSTM. So it's the papers from the Deep Western. The original author of LSA, he has all the parameter in the paper, and usually I just run through my tutorial to show the people how you can do the step by step to doing the topic model analysis. The next method we want to call here is the n-gram. So n-gram is a sequence of the word or the linguistic term. So, for example, here in this sentence, George is a unigram. George Washington, if we treat them as a special meaning, then this is called the bigram, it's two words. And the George Washington University is a trigram. So, and then you may have several consecutive terms together, and we call this as an n-gram. Why we need to use an n-gram? So we generate a model of the probability, saying, given a word, WI, what is the, co-occurrence in this, previous word in a string. And then if you sum all of them together, then you get the probability of this n-gram. And the nice of that is, you can use that to estimate what the weighting of the word in its neighbors. So this is useful. But the challenge is which one, how you want to choose how many n, which n is optimal. So it has an exponential combination. So not very easy to determine. And the second model is the other model is called the neural network language model. It's published by the famous the machine learning expert Benziel from the University of Montreal. So his idea is to try to reduce the dimensionality of the W, the string of the word. and by projection doing the low rank space by the training model. But this is also very expensive. So there are several other models also trying, but it's very, the challenge is the computation complexity or the computation cost. So it's very, very huge. And until 2011, so Thomas Miklo, he used to work for Google, and then now he's the research scientist at Facebook. So he published his thesis. He combined the N-gram method and the neural network language model together. It's called the skip-gram neural network model. And then here his realization of the method is called the waterlet. So it's now available in the TensorFlow and also in the Jensen. So the method is very simple. You can, it's only 2 steps. The first step is to build the background and from the previous encoding words. For the forward, so it just take the previous n-1 word, and the recurrent architecture just take all the previous word. So this is the only difference in this architecture. So if you are interested to understand the detail, you can download his thesis online, so you can look at what is all the math detail and how he put out the implementation. So I just like to show the simple example of what is mean the background the NLM. So you have a source data saying Samantha bit is another bit. So starting from the first word Samantha, right? So you can do the generate the background in your training data by Samantha and bit, and then Samantha and the east. So you have the window equal to 2. So for the central word, you can go left or right, but you cannot exceed the window size of 2. And then if you go to the second word, now you point to the bit. So you can say you have a bit Samantha and the bit east and the bit not. So that is the second and the third one and the fourth one and so on. Until then you generate the training data set, and then you compute the occurrence of the particular background, and then you generate the training the probability, and then you can apply it based on the statistics. Then you can tell which one has more chance than. So saying if you have an input saying Samantha and the bit, certainly it will be much more than the Samantha and the bit, because based on the occurrence, co-occurrence of 2 words, then you can find out, actually the Samantha and the bit happen more than the Samantha and the bit. And then he applied his very smart after he generated this the pseudo training data. Then he plugged into we call the recurrent neural network model, and he solved the problem very nicely. Now we want to show, and it's one of the hot topic in today's the NLP implementation. So this is a very simple neural network model. So it contains only 3 layers. It's an input, hidden layer, and output. Very simple. So the U is between the input and the hidden layer, and the V is between the hidden layer and the output. And for the recurrent neural network model, actually is you also receive the input from the previous hidden layer. In this example, it is ST-1, the previous one. So then in this case, then you have a U and a V and a W. So the input between, so the match the U and W will be the input to the new, the hidden layer, and the output is the same. So statistic, so if we're looking into how this is derived, so it actually is using the computation of the summation of all the previous input, and then the previous input, previous the hidden layer, and the current input with we call the sigmoid function. And then at output is applied the softmax abbreviation function. So this is the method he implement his thesis. But later on we can discuss. There's some problem. And then so this is the formula we write in the matrix form. It's a very trivial, very simple, and very elegant to solve this problem. But the problem is that if we have an error, you propagate to the output. How do we correct the error? So then it is called backpropagation. So using the backpropagation to do the correction of the error, and then basically is that you compute using the trend by the stochastic gradient descent. So this is a method to do the correction, and you try to find out what is the gradient. So, but in most of the cases, you have huge data. You will see the gradient is up and down. So it's very difficult to compute the very precise gradient, which one to pick. Instead of take point-wise gradient, you just take a range of the point. So it's called stochastic gradient. So you set a range, then you take an average, and this is how this method works. And this is the 3 layers model. So you can see, the current layer ST actually is affected by the ST-1, ST-2, ST-3. This is a propagate in this way. And so the work-back method is, as I said earlier, it is a realization of his work of the SCCM model. And if we look at this model horizontally, then you can see, the every layer is a 3-point, the 3 layer, and then the dependency is, only on the hidden layer. This is what we call the unload, the INN, recurrent network. But the problem is the same. If the same, my current output depends on not just the previous hidden layer, and also depends on previous input and output. What can we do? So this is the associated problem of the memory. So in order to solve this problem, some method has been invented. So by the Hawk writer and the Benjio, so they realized this is not sufficient. So we need to have a memory. And how much memory do we have? So instead of have a long-term memory, it breaks into a long, short-term memory. So have a short memory, and it keeps track of those memory in order to do that. So currently, the LSTM has been used, implemented in the several products by Microsoft, Facebook, and Google. So, for example, in Google's latest, the Gmail smart reply function actually is implemented with the LSTM. So, if you try your the Gmail on your smartphone, then when you type something, then you receive the email before you type in the reply. It will suggest some the sentence for you. So that is implemented by this method. And so if we compare the previous layer, so the problem here is the previous hidden layer it doesn't have a storage of the previous the input and output. It only store the previous the hidden layer information. So you can see, and in order to improve that, there's a method is to implement the redesign the hidden layer, and by breaking into the 3 gates. One is called a forget gate, input gate, and the output gate. So they are the 3, and then you control the state of the cell. So instead of just giving the output, now you need to also consider the state of the new hidden layer. So the first step is based on the previous output and the new input. You determine which part you want to keep. So using the sigmoid function, it's very simple. And the generated output function is called FT. So FT is the threshold. And the second layer, and then the second layer is the input gate. So then you're using the previous output and the new input. Then you will try to compute the input function. Input gate is called IT, and based on that, you determine the state of the pseudo pseudo input state called C hat T with the hyperbolic tangent function. So then you determine the quantity, and then you're using the formula to multiply the previous the state, the t-1, with the how you want to let it pass or not, 0, 1, and then the new input gate and the input gate indicator, and also the volume of the state. And then this is also the method. Then based on that, you can continue to compute how much you want to go out to the output gate, and what is and using the defined function to compute what exactly you really want to output. So this is a function that you have a sigmoid function to determine yes or no, and then the tangent the hyperbolic tangent for the computed, the state CT, and this is your final output. So, and actually, this implementation has been done in the TensorFlow. It's very easy. So the model of LSTM is you just need to specify, your input vector, your weight, your bias, and then you determine, sum of how long of the string, and then you can compute. So it's only a few lines. So if you really want to see how this works, there are some tools in the GitHub. So you can search the LSTM by example using TensorFlow. So there are yeah. Oh, 5 more minutes. Okay. Yes, and there's more methods you can apply in this method. So some application, as people using that, is very popular for the sentimental analysis. So the Y here will be, positive, negative, or neutral, like Facebook, like or dislike, right? And another one is in recent days. Using a lot by the financial industry. They are trying to say if any new financial report coming out, what will be the most important information. So like last week, Amazon stock jumped 13% to the new record high. So you can tag in with the different entity, organization, percentage, and the monetary, and so on. So this is the application of, and there are the many important. The ML software could be useful, like a cafe, couch, TensorFlow, and so on. And then The last section is reasoning. So reasoning is try to generate the intent to construct the answer. So the intent actually is different from the we call the pragmatic. It's different from the semantic. It's more subjective. We try to understand what the really question the speaker asks in order to generate an answer. So there are some implication and the background assumption. Like I have to start smoking means the speaker has smoked for quite a while. And so that is the implication. We have to build some mechanism to understand the implication on the background. And then the second part is how to answer. Once you have an intention, you have a semantic, you search a bunch of results, how do you want to answer? So first method is by the first order logic. I think most of the people learn this one in the CS process, but actually this is only for QE, for education. It's very difficult to scale up, so it's not very useful. And the second one is by the friend semantic. So this method is related to the parsing. So the idea is very simple. You search for the verb of the sentence, then you build the framework. So how to do that? For example, if we have a gift advice, Mario bought a dress for $300. You see, the verb is a bought, and therefore we can build a frame like, the buyer, the seller, the product, the price. Then this is the brand. So it's all based on that, and then you can map in based on the dependency parsing to the frame. So you can plug in the data, and then you can also cover for the alternative question. So we can use in one frame to describe the question in a different way. And okay, and then so this frame semantic actually is later on multiply as more generic, and it's called ontology. So in some way now it's very difficult to differentiate the ontology and the object-oriented programming. So it looks very similar, and the people are now just using the object-oriented programming to replace, and you can use that to build a knowledge base directly on the knowledge graph directly. Yeah. And then the last question is, how do you do the reason? How do you update your knowledge base? So because the GPU now is very cheap, very powerful, so it's not a problem to have a system automatically to update the knowledge, or to resolve the conflict of the knowledge. So and then the human's intervention is becoming less and less. And that's my conclusion. So you see, in this NLU engine development, I propose there's a three-step: parsing, understanding, and reasoning. So parsing is mapping the question to the structure. Understanding is understand the content of the sentence. And then the reasoning is to figure out the intention in order to summarize all the information to present it to the speaker in appropriate way. But there are some issues, as pointed out by Andrew in his the Harvard Business Review article. There's two issues. When we build the natural language understanding engine, one is a data source. The data source is not that easy, especially for the startup company to acquire or access the rich data. Most of the data is dominated by the big player. And the second one is the talent. So the talent is another issue. Just download the open source and the play is not enough. So you also need to incorporate the domain knowledge and to differentiate what the AI can do. So the AI can do is not to generalize, it's try to personalize or to customize. So this is a very different approach from the people always think, okay, I using AI I can generalize, but there's some question recently raised by the Kun, who is the boss of the Facebook, the AI head. He is saying, no, for the general AI or the general NLP, NLU is challenging. But we can do is a narrow AI, which means the domain specific, the application, this is durable. So end-to-end, we heard the same argument saying, okay, there's some topic like, you're doing the camera integration, then this is very useful for the self-driving cars. So that is he identified in his article several applications. It looks promising to using the nano AI instead of the general AI. So the general AI, in my understanding, is still a long way to go. From 20 years when I started working in this field, up to now I see the advancement, but I still, that's very difficult to generalize the intelligence. So we can do the more specific and the domain-wise the intelligence. That is possible. People trying to build like a building block and put together, and then to simplify, a lot of the challenge what we faced in the past. Okay.
All right, thank you very much.
Yeah.
So, as is our tradition, we have a little bit of time for questions and answers, and I really want to encourage everybody to take the opportunity to ask Dr. Sun some questions. This is an extraordinary opportunity to learn a little bit about NLP. So, let me come around. If you have a question, raise your hand. I'll come by with the mic. When you have the mic, please give your name, and maybe if you're affiliated with some institution, let us know. And be sure to talk into the mic so our viewers at home will hear not only the great answer, but the question that caused it.
Yeah.
Hi, Dr. Sun. Thanks for the talk. This is Lei. I'm a chief data scientist at Clary, so I actually gave a talk at this meetup a couple of weeks ago.
Yeah.
So thanks a lot for the introduction about the natural language understanding. Can you give us kind of like just using the example you shared on banter.ai, like how this parsing, understanding, and reasoning will use there? Because I saw there are 3 different steps. Like from parsing, I can get a tree. But how is that tree used for the next step? Like how does that help for understanding, and then how is understanding lead to the reasoning?
Yeah.
And then the last one, because I checked the website, it said that it's more like a chatbot, right? So how do you come up with some response which are human understandable?
Yeah. I think this is the all secret sauce how we handle this, the process. So the first thing, as I say, in that is when the chatbot, the banter receive, the question, the best case is to try to, do the standard NLP to, and to understand the structure and then narrow down how many possible structure, and then based on that structure, then we analyze with our machine learning program, so we can further pick up maybe it mean this one or mean this one, and then the question there will be, then we start to generate data. So then we look at that. If we cannot generate the sufficient data, saying if we return no data, I can think is maybe the question is not well defined, and then I will construct a new question to ask the speaker back in order to narrow down the question. So that's one approach. The second approach is if I receive hundreds of data, means my data is too broad, then I also need to add more filter in order to shrink the size down. So then we have for each different product we have some number of the product we want to show the customer, saying if I have 20 product or 50 product, I may just want to show the top 5 or top 3 and see if the customer wants. So you customer pick up one of them, then we can further carry on the conversation. So the idea is, the conversation flow, you can last very long, take a 10, 20, 30 sentence to reach the same conclusion, or you can, route your dialogue flow smarter, so in order to shorten the conversation. Yeah.
Arthur Zinger looking for, several times you mentioned the heavy computational burden. To what extent can or cannot you substitute a standardized pre-computed reduction on the grammar and on the clustering rather than do it on your specific data?
Yeah. So that is very interesting. So so this is the first step we doing, the parsing method. We try to say, if I generate the parsing tree, I may have many parsing tree, right? If it depends on the sentence. If some of the sentence is very sophisticated, then it can further down generate the hundreds of the parsing tree, and it's more difficult to pick up. So in that case, then we say, enough. If we find out there are too many, then we may start to, introduce the content. So we cannot just based on the structure. We also need to measure by the content. So the content, the semantic will help us to reduce the size or the potential meaning of the question. Yeah. So this is like you have a structure, then you have a generate the weight, and then iteratively to reduce until a certain size you think you're comfortable to solve. Yeah.
Hello, thank you for the presentation again. Yes, Randy. Oh yeah, I'm Michael. I'm just an engineer at Microsoft, and I was curious. You mentioned Banter is, I guess, it's a growing company. When you pick up new employees, like pick up new people on the team, I was wondering, what did you find most helpful for helping them understand how to work on the project? Like, especially some of these problems with adapting new models, such as like the idea of using not just feed-forward, but also combine that with recurring to solve the dimensionality problem. That's not something that comes easy exactly.
Yes, okay.
There's a reason it's still in like research papers. So I was wondering, what did you find help people get accustomed to being part of the team the most and provide a useful impact quickly?
Exactly. Yeah. So the customer's environment is always very important, because when we define the conversation, the terminology, we cannot do it by ourselves. We have to work with the customer. So to understand what kind of the vocabulary, what kind of the term, what kind of knowledge they use to serve their customer, and we just help them to automate this process. Yeah.
Okay, one more question?
Thanks. My name is Stephen, NLP consultant. With regard to banter, what are like the top 5 reasons why, let's say, the customer inquiry fails to convert? Is it, bouncing, conversation was too long, customer wasn't precise enough, item wasn't in the inventory, or even to what extent can you develop an inference of why that is to help the customers improve?
I couldn't quite understand. Can you repeat again?
Yeah. What are the top 5 reasons with banter that a conversation might fail to convert into a sale? Is it the conversation was too long, the customer wasn't precise, the inventory didn't satisfy the customer?
Yeah. So there are several reasons. We built the metrics to justify a successful conversation or it's a fair conversation. So some criteria is the conversation exceed the threshold, then within also looping the conversation. It means that this conversation will not get a result. Or is a conversation, it didn't reach the conversation, it didn't reach the conclusion or the product or the answer to the question. For example, the customer may check my the order status, and the chatbot may repeat ask the question where you are with your number. So that is the starting point may indicate this is the failure of the conversation. So for each conversation, we have the log, and then we have the support expert to looking into and give the score. Is this is good enough? Is this is the So they give a score saying, okay, this is pass, this is a super, this one is fail, and then we use this one as using this score to perform the reinforced learning. Yeah, and then we can improve, our conversation. Say, if we later on, then we can build, the decision tree, so we can understand if this is fall into this path, what kind of the conversation should be carried on, right? So we can work by the type, by the content, and then that is as a guideline to serve the customer. Yeah. Okay.
All right, thank you everybody for coming. And can we all give Dr. Sun a great big hand for what thank you so much for taking the time with us. So we're wrapping up now for the talk part, but this is the time to say hello to the people sitting next to you and spend a little bit of time getting to know the fellow guests here. Yeah. There's a room full of fantastic people, so please take the opportunity to get to know somebody new tonight. All right, thank you.
Yeah.